a definition of this phrase, and it is going to kick off our discussion. So let's do it now. Please raise your hand electronically if you can tell me what is a silver lining. So I'm going to start with, I've got Jack, unmute. Go for it, Jack.
It means like if there's something that's not the best, there's always something to make it not the worst.
Whoa, I love that explanation. And let me just go to, let's see, Charlotte, go for it.
Silver linings actually can be really bad, because if somebody's in a situation where they would like to hear a silver lining, there's an example, and it's, you can't just silver line something that somebody feels either really bad about or is really sad about. You can't just be like, oh well, and then just a silver lining. Sometimes it's just, you shouldn't do that.
Wow. Well, I have to tell you, Charlotte, that has particular meaning for me, and I really appreciate that, because, you know, last year I was going through something really bad. So I had cancer last year, and a lot of times people would try to paint a silver lining on that. And you're right. I did not want to hear all that rainbow stuff when I was feeling, you know, and going through chemo and all that stuff. So I have to tell you, you have given me a perspective that is really meaningful. So I thank you. And is anybody else going to tell me their perspective of silver lining? Luca, you had your hand up. Go for it.
The best thing out of a bad thing.
Yeah, you know, I wonder if you guys can now raise your hand if you can tell me a silver lining that has come out of COVID for you. And I have talked to a lot of students, and I would say that at least 95% of them have something there. So I'm going to start with you, and Luca, that was beautiful. And Charlotte, thank you, and Jack. Michael, I'm going to start with you. Go for it. And Michael, I'm hitting unmute, trying to unmute you. So if you can.
I didn't mean to raise my hand.
Oh, okay. So Frankie, go for it.
I think that there's something like I get to spend a lot more time with my family and see them more than I usually do.
Isn't that a wonderful silver lining? I hope that that continues for you after it's done. So thank you so much for that. And Sam, what about you?
Less schoolwork.
Less schoolwork. That can be a silver lining. It can cut both ways. It can definitely cut both ways. I love it.
Sam, I think we have the same amount of schoolwork as we usually do.
Well, you know what, though? I have to tell you something. It may very well be that it feels like you have less schoolwork because maybe you have more time in which to do it. And so, Sam, I love your perspective. That was very cool. Hannah, I'm going to choose you. Go for it.
We've been spending a lot of more time in our home, and not because usually every spring we're every weekend we have so much to do, and we're always at a soccer or lacrosse game, and now every weekend we have nothing to do, and our schedules.
Same.
My dad loves it.
Now, is that a silver lining for you?
Well, it's good and bad, because I like to be home, but then I want to compete in a sport.
Same.
Totally awesome. And Adelia?
I have more time to bike.
You know, that is awesome. I'm really glad you shared that, because right after this class, that's what I'm going to do. And I get a lot more time to bike now. So thank you for sharing that. And how about you, Michael?
I get a lot more time to do stuff that I usually can't do. on the weekdays because I don't have as much time.
Cool. That's great. That's great. You know, time. We really have a lot more time to do these things now. Thank you, Michael. Andy, I want to hear from you. And then Jack and Luca. Go ahead, Andy.
With the biking, I just came back from a bike ride and then I got on this call.
Great. That is fantastic. And what about you, Jack?
I have a lot more time to like just do what like I can draw more cartoons now, which is something I've always liked to do. I can practice music more. Like I used to feel like I have to like set a 10-minute timer and then go do something else, and now I don't. And I can
Wow.
just
That's awesome, man. I am so happy for you because I love drawing. In fact, I paint oils, and you know, this is just an oil I can show you. I don't know if you can see it through the green screen. I hate this virtual background thing, but in any event, I'll try to show it to you later. But it's one of my favorite oils, so I'm so glad you shared that. And Luca, go for it.
Doesn't really relate to me. So my mom, she's still she works with babies, and she said a silver lining about it is that some parents, they're so much happier because they don't have like all their aunts and grandmas and grandpas just like clouding the baby.
Wow, that is a really interesting silver lining. Now, guys, I want to share with you my silver lining in this COVID situation, and that is that I've been traveling a lot throughout my lifetime, and I've gone to Europe and Asia and Africa many times, and I've developed many close friends, and I have fallen out of touch with those friends over the years, and I have recently reconnected. So every week, I would say about 4 or 5 times a week, I do a sort of a cocktail party with my friends where we sit around and we'll drink our soda and our water, and we'll just hang out and maybe have dinner together, but we're online together, and they're in Denmark, and they're in Zurich, and they're in Africa, they're wherever they are, and I get to be with them. And so that's a huge silver lining for me. And I really hope that some of you can reconnect as well. And Michael, you have one more from you, Michael, and then I want to move on. Go ahead.
This isn't really about the silver lining, but the problem with this coronavirus is that my mom, she doesn't have less work. She kind of has more work because she worked at a place that develops medicines for stuff like the coronavirus. So now she has to work a lot more.
Well, I have to say, and I want to say this on everyone's behalf, that we really appreciate what your mom is doing, that the people that are in the healthcare field, like my wife, who's a pediatrician and works really hard with kids now, it's hard because they're on the front lines. And Michael, I really, my heart goes out to your mom. Thank you very much. Now, I want to tell you the silver lining that has happened in our world today. And it is this, guys. I want you to look at a picture right now that you see in front of you. This is called Delhi, India. It is one of the largest cities in the world, and it is also one of the most polluted cities in the world. So Delhi, India, on the left, you see what the sky looked like in Delhi 1 year ago. And today, it is completely clear. Now, this, I don't know if it's going to continue, but the most amazing thing that I learned is that people in northern India, some of them who live at the foot of the Himalayan mountains, this is the Himalayan mountains. Now, there are literally tens of millions of people that live near the Himalaya mountains, which extend to Mount Everest. And for the last 30 years, I want you guys to think about this. You're only, what, 9, 10, 11 years old. For the last 30 years, no one in these places has been able to see the mountains because it is completely covered in pollution. And about a month ago, they woke up one morning and, oh my God, I live near the greatest mountain range in the world. Now, you would think that they would know their geography, but they don't because they're very, very poor. And a lot of people who are poor that live in certain parts of the world, they don't have the education that you have to understand that they live near a mountain range. So this is one of the great things that have come out of COVID. And now I want to talk to you about the WHO, the WHO, which is the World Health Organization. Now, the World Health Organization has come out and basically said that if the level of nitrogen dioxide is greater than 200 micrograms per cubic meter, that is considered a very, very unsafe level of air pollution. Now, I want to show you what that looks like. This is a cubic meter. It is a 1 meter by 1 meter by 1 meter. All three dimensions are 1 meter. And I've given you little yellow dots representing micrograms. So I've hoped that I have more than 200 of them, but essentially micrograms are really, really small. And if your cubic meter of air is filled with more than 200 particles of nitrogen dioxide, it is very, very unhealthy. People with diseases, asthma, people that get affected by viruses and bacteria and microorganisms, during high pollution, they have very low immunity and they can't fight off the disease. Who can tell me some other great things that come from a lack of pollution? What are some of the other really, really cool things? Jack, go for it.
When you see what it's like without pollution, you want to keep it, so you work harder to stop it.
Jack, I do not know if we're going to be able to go back. I really worry that when COVID ends and that everybody is back to driving their cars and driving their boats and driving their trucks and opening their factories, will people go back to their old ways? Right now, do you know what else is happening? All the crops are growing at a much more abundant rate. So crops are growing. People are putting less waste in landfills. Pretty amazing stuff. Now, I want to ask a question right now. Can anyone tell me the number of cubic centimeters? The number of cubic centimeters in 1 cubic meter. So I want you to send me a chat, please, and raise your hand if you know how many cubic centimeters is in 1 cubic meter. And also, I'm just going to set out for you that there are 100 centimeters in every linear meter. 100 centimeters. So I'm looking for your chats right now. I don't have the right answer yet. Oh, by the way, Elliot, thank you for counting the dots for me. I appreciate that. That was very cool. And I'm looking for anyone that can tell me how many cubic centimeters there are. Now, ooh, Adalia, You nailed it. Can you please tell them how you came up with your calculation?
I multiplied 100 by, wait, no. I don't really remember.
Okay, so you multiplied 100 centimeters by 100 centimeters by 100 centimeters. And how did you come up with 1 million cubic centimeters? Because you totally nailed it. You want to share that? Anybody else want to share how 100 times 100 times 100? Luca, go for it.
Because with 100 times 100, it just forces you to do 1 plus 1 times 1 equals obviously 1. And then you just add 4 zeros. And then you do it again. And then you add 6 zeros. Then
That's right. That's a great way of doing it. The number of zeros, when you multiply them, you simply add them. And all that really means is place value. So 1 million cubic centimeters is 10 to the 6th power cubic centimeters. Now, everyone, let's look at micrograms. Micrograms, 1,000 micrograms is equal to just 1 cubic centimeter. So if every cubic meter has 1 million cubic centimeters and we multiply 1,000 times a million, come on, I know some of you've got this. I know some of you have this. I'm gonna unmute everybody now. Say it on 3. And Charlotte, we'll start with you. 1, 2, 3, go.
1 billion. 1 billion.
Yes, guys, there are 1 billion micrograms. There are 1 billion micrograms in 1 cubic meter. So therefore, if unhealthy levels of NO2 are greater than 200 micrograms out of 1 billion micrograms, who can tell me right now, who can tell me the ratio of nitrogen dioxide to 1 meter? What is that ratio? Shar, do you have that for me?
Yeah. Isn't it 500 million?
Well, you're getting there. You're getting there. Let's think about that. If we divide both top and bottom of our fraction by 100, what does everybody think we have left? I'm going to unmute everybody, and I want you to tell me what I have right now. On 3, 1, 2, 3, go.
10 million.
Yeah, 2 billion.
2
No, 10 million.
over 10 million. And 2 over 10 million is equivalent to what, everyone? Go.
1 out of 5 million.
5.
And that's it, guys. The next time you guys look, the next time you look at the air, I want you to think, if there is more than 1 microgram of nitrogen dioxide out of 5 million micrograms of a cubic meter, then guess what? It is unhealthy. And I want to show you what that looks like right now, okay? I want to show you what that looks like right now. In China, and this was about 4 months ago, this is the area from Hong Kong to Wuhan, where the virus began, to Beijing, right here. Very, very, very dark orange. Now, what does that mean? It means a level of density of nitrogen dioxide of greater than 200, which is considered unsafe for humans. Now, I've been to Beijing, and man, it is a very, very dirty city from in terms of its the air. When I went running every morning when I was there, it really was difficult to breathe. And I found myself coughing just because it was hard to breathe. Now, look at the same area 1 month later in February. It's almost completely clear. Now, look at Wuhan itself. Wuhan was one of the dirtiest places in the world in terms of the level of nitrogen dioxide. 1 year later, it is literally almost clear. I mean, I'm blown away. I want to go to Wuhan. That's where I want to go, okay? And I want to go to India. So this is amazing stuff. Now, some of the other places, I want to talk to you a little bit about Northern Italy. So Northern Italy has a really interesting geographic problem. Their geographic problem is that Northern Italy is just to the south of the Alps mountain range. And the Alps mountain range is trapping all of the pollution in Northern Italy. So a year ago, Northern Italy was unbelievably polluted. But post-COVID, guess what, guys? It's starting to clear up. They've reduced their levels by more than 40%. Now, let's talk about where we live. This is where we live. This is the Northeast United States. And in the Northeast United States, from Massachusetts, from let's say, what is this, Vermont and New Hampshire, Massachusetts, Connecticut, Rhode Island, New Jersey, New York, Pennsylvania, Maryland, all of these places are really considered somewhat polluted from an air standpoint. Now, Boston is a little bit better. As you can see, New York City and half of Long Island is in a very dangerous area of health and pollution. And I want to show you what happens a year later. A year later, this is a picture now taken from the Aura satellite of NASA that detects the amount of nitrogen dioxide. And the levels are down 30% everywhere. Look at what Boston looks like right now. It is unbelievably clear. Even New Jersey is improving. New York City is improving. Long Island is improving. Washington, D.C. And it's really, really exciting. Now, let's go to the rest of the world. Everyone go to page 6, please, right now. Everyone go to page 6 in their packet if they have it. Now, if you got page 6 in your packet, I want you to tell me what about this graphic is a little bit puzzling to you. There is something about this graphic that I am having trouble computing. I'm having trouble and I need help here. So I'm going to ask Cooper to start me off. Go.
Rome went up by 30%.
Whoa. Now that is troubling. Everywhere else around the world is going down in pollution levels, but Rome is going up. Does anybody have any theories? Brett, can you help me out here? Do you have any theories about why Rome is having such trouble?
Maybe because the coronavirus was in Rome for a long time, and
You know what? You're right. You're 100% right that it was there, but why would that make the pollution level go up? And I need to ask you guys to give me your theories. I have a theory, but I don't know if it's right. And Charlotte?
My theory is that haven't their cases lowered quite a bit?
The number of corona cases have definitely lowered quite a bit.
So then they're probably making up for lost money and time in manufacturing their goods.
You know, it's interesting to me that all factories have not been shut, correct? And I wonder, Charlotte, if that's a really good conjecture that maybe there are factories in Rome that are considered essential factories that have to stay open. And I don't know if that's true. I really want to do some more research there. Thank you for that. And Luca, tell me what your thoughts are. I want to hear, I want to get to the bottom of this problem.
So I went to Rome a few years ago, but I really don't understand why it's gone up 30%. Because like Rome was very polluted because cars are crazy there.
They are really, really crazy. When I was 20 years old, now guys, you can't imagine this, 38 years ago, I was in Rome for the first time, driving a motorcycle on the streets of Rome, and I almost got killed about 100 times. So Rome was crazy 38 years ago and polluted. And yes, I would have thought that Rome would have come down in pollution. But here's my theory. I have two theories. Number one, it has been very cold in Rome this winter. Now, people in Rome are used to being outside. They love being outside, driving their cars and walking, and just Rome is a very, very metropolitan city. Everybody has been in their house scared for the last 3 or 4 months. And guess what? They're using their heat. They're using more energy. And I think that their heaters are causing nitrogen dioxide into the air at higher levels than before. And the other thing is, there may be electricity plants that are close by to Rome, and that's why it's happening. Shar, what do you think?
Well, I also think that pollution is going to skyrocket after this because of my theory of them factories making up for lost money.
I know, but can't they come up with alternative energy? This is the time. This is the time to do it. And Charlotte, believe it or not, I have heard that a lot of companies in the last 4 months, because they haven't been working, they've been spending all their time thinking about alternative energy sources and ways to replace it. So I think you may be right. I hope you're wrong, because I don't want to go back to that level of pollution. Now, I want you guys to do this for me. Everybody go to this little graph here. Now, this is kind of fun to do because you get to shade in. I like to take a crayon or a highlighter or a colored pencil, and I'll shade in 25% reduction in New York, because each of these boxes represents 10%. And then I'll take a little square rectangle and I'll say, okay, what is the complement of 25%? Who can tell me? Now, the complement means the difference between 100%. So if Los Angeles reduced their pollution by 31%, the complement of that is a 69% pollution remaining. Who can tell me the complement of New York? On 3, 1, 2, 3, go.
75.
75.
That's right. 75% of pollution is remaining. Now, what I want to know is, what are we going to do about Rome? Because the shaded portion The shaded portion represents the reduction of pollution. Rome has not had a reduction of pollution. Bobby, I want you to give me a strategy to deal with Rome, please.
I think since on the left side it's what hasn't gone down, then you would just put it on the left side. You would shade on the left side.
Okay, so shading on the left side. And Adalia, what do you think about that? No, I'm sorry.
Could also
yeah.
switch the colors.
Ooh, I could switch the colors. And what I'm worried about, though, is if shading represents reduction, what could I do alternatively that will represent an increase? Luca.
Add more boxes.
Guys, guess where we are? I just took Bobby and Adalia's idea of putting 30% in a different place. And with Luca's idea, I've actually added it to the 100%. Now on 3, everybody, I want you to tell me the remaining amount of pollution in Rome. On 3, 1, 2, 3, go.
100%.
And guys, if you said 130%, you are correct. It doesn't seem possible that you could have 130% of something, but yes, that's what happens when you have a fixed amount of pollution and then that pollution grows and grows. Now, who can give me the complement of Sao Paulo? On 3, Sao Paulo. 1, 2, 3, go.
67.
67%. The complement of London, go.
91%.
Whoa, 91%. London better do a better job. They have a lot of cars, though. A lot of pollution there. Okay, Madrid, on 3, 1, 2, 3, go.
89%.
89%. And my favorite reduction of all is Delhi. On 3, 1, 2, 3.
40%.
40%. Give me Mumbai.
66%.
6%. Give me Wuhan.
56%.
And 56%. Now, my dad used to live in Seoul, Korea. They've had one of the biggest reductions of pollution. Go for it, guys.
46%.
46%. Now, guys, I don't think we'll ever go down to levels of no pollution, but man, it is exciting to think about it, and I wonder if we'll ever get there. Now, take a little journey with me. A lot of you were not on the call last week, but last week we talked about latitude and longitude, okay? And oh, Liam, you've got to stop that, buddy. Liam, because that's very distracting to other people. Thank you very much. I appreciate that. We talked about latitude, longitude, which starts with a circle of 360 degrees. So I broke up the circle into 10% increments. And how did I come up with 36 degrees for each increment? Who can raise their hand electronically and give me the formula for finding that 36%? Come on, somebody who hasn't shared yet today, I'd love to hear from you. Elliot, what do you think?
I think it's because there's 360 degrees and 360 divided by 10 is 36.
And that is a great answer. And I want to ask anyone else, does anybody have a theory of how I was able to draw 10% increments so equally? I mean, it's hard to break things up into tens. Can anyone tell me what I did here? And by the way, little hint, I cheated, okay? I cheated. What did I do to create this beautiful group of sectors. Anybody have an idea? Dahlia or Frankie, do you have any ideas for me?
You use the computer?
Well, I definitely use the computer, but still, I made the lines manually. Frankie, what do you think I did?
I think you did the 36% first because they're smaller, and then you did the 10. Like,
Well, you know what, guys? If I had thought about it, I would have used a protractor. And can you guys see that this protractor is showing 36% right there? Isn't that pretty cool?
Yeah.
But I wish that I had done that. I did not do that, okay? And so I wonder if you know another way to do it. Okay, watch this, guys. I overlaid a regular decagon on the circle and simply connected the vertices. So I know it was cheating, and now I want to see if you guys can do it. So everybody go to page 8 in your packet, where I broke up every single city into circles, and I want to give you all my best practice here. So my best practice is go to Sao Paulo, please, which is in Brazil, and I want you to draw a vertical diameter. A vertical diameter means that you're going from one end of the circle to the other, and you're going through the center of the circle. So do the best job that you can there. And Brett, you have a question. Go for it.
Can we use a ruler to do this?
Absolutely. I told your parents rulers would be great for this lesson, and as well as colored pencils. So definitely. And Frankie and Adalia and Luca, do you have a question, or are those hands up from before? If they are, that's okay. No worries. Now, I want you guys to take your marker. Look along the 180-degree arc. Look along the 180-degree arc, and I want you to draw 4 dots that are equally spaced. If you draw 4 dots that are equally spaced, and I really don't like my first attempt, so I'm going to erase that. It's not easy to do. There's my first one. Then I go half. One more. I like that a little bit better. And once you have separated your 180 degrees by fifths, you're literally breaking things up into fifths. Then I want you to take your ruler, if you have a ruler like Brett, and I want you to go right across from each dot through the center and all the way to the other side. And you just created 2 tenths. Now you've created 4 tenths. Now you've created 6 tenths. And now you've created 10 tenths. And that is my sort of non-cheating method of how to do that. I have a philosophical question for you. Can anybody answer this? Why are Americans really bad at breaking things up into fifths and tenths? And why are people around the world really good at it? We are really good at breaking things up into halves, quarters, eighths, 16th, and so forth. But why are we bad at tenths? So I want, okay, hands up, Adalia, go for it.
This isn't why we're bad, but other people use the metric system, and that probably helps a little bit.
Adalia, that's exactly why they're better. They are better because they think in tenths, they do everything in tenths. And Luca, what were you going to add to that?
Same thing.
Same thing. Good. Anybody else? Cooper, you as well?
Just gonna do the same thing.
Okay, cool. Now, guys, we are really good at a lot of things. We're just not good at tenths. And in fact, I'm really sad that we don't have the metric system. And I want to ask you this question. What are we going to do about Rome? What are we going to do about Rome here? Mitch, do you have an idea?
No.
Okay, I thought you were raising your hand. Anybody else? What are we going to do about Rome? We've got a problem here. And who's gonna share here? Luca, go for it.
You divide it into 13.
Into 14ths.
No, 13.
Oh, 13ths. Interesting. You know, I like it, but I want someone else to challenge it. I love it. I love it. Andy, go for it.
We add a second circle.
Ah, I like it. Everybody think about how you could add on a second circle or just steal 3 of the sectors. By the way, each and every one of these is called a sector. The next time you're out having pizza, for me, it will be tonight. We're ordering in, okay? When somebody hasn't eaten their piece and you say, hey, are you going to eat that? You say, hey, are you going to eat that sector? Because a piece of pizza is formed by 2 radii and an arc of a circle. That's what a sector is. So let's see if you guys could draw 3 extra sectors for Rome, representing an additional 30%. So this was my not very good rendition. I hope you guys are working on this. And I want to throw another challenge in here. I want you guys to give me the degree measurement. So for instance, New York, we know is 25% reduction in pollution, which is 2.5 of these sectors. Now, who can tell me the degree measurement of each of these pieces? So come on, raise your hand. Tell me what these pieces are. Bobby, go for it.
I don't
This
know.
one is what? That first one is 36. What's the second one?
36.
And what's the third one? Because this one is just half of one of those 10%.
18.
That's right. Now, everybody, all we have to do is add 36, 36, and 18. Help me out. On 3, everybody. 1, 2, 3, go.
90.
And
90.
if you, wow.
Oh,
Yep. So this is 90 degrees. That is 90 degrees. Very, very cool. And I want you guys to work on as many of these as you can. So Luca, you keep working. And if anybody has any questions, raise your hand electronically and I'll take you through any of these that you want. And I'm gonna cheat a little bit here, guys. My circles.
Cheating.
Just because I don't have cool rulers like you guys,
I don't have a ruler.
Wait, you're doing this longhand?
Well, I don't have a ruler on this.
And by the way, if anybody wants to see, I can show you how to create a ruler out of a piece of paper.
I already know.
Cool.
Didn't you already tell us that?
Say again?
Didn't you already tell us how to do that a couple lessons ago?
I hope I have, but it doesn't hurt to hear it again. So I'm going to work on Seoul, Korea, because that's where my dad used to live. And
That's cool.
54%. So I'm going to start with coloring half of my circle, which is a semicircle. I don't know how good my little 4% was. Who can tell me what that additional 4% piece would represent? Can anybody help me out with that? What would that additional 4% be? Because I know that each of these is 36. Can anybody raise their hand electronically and help me with that? Adalia, can you help me with that one?
9?
9 would definitely be right if it were an additional 2.5%, because 2.5% is 1/4 of 10%. I like 9. 9 was a good one, but 9 degrees represents 2.5%. And I'm looking for an additional 4%. So that was a great start. Anybody else have a way to get me there? You could multiply 4 by 36. Does anybody know how to double 36?
144. It's a gross.
If you said gross, if you said 144, which is literally gross, we know, and Adalia, look at this. I'm going to put the little decimal right there. And so 4% is exactly 14.4 additional degrees. Now, I need help from someone else to tell me how to multiply 36 by 5. I want an algorithm to do that. Who's got an algorithm for 36 times 5? I want an idea. Hannah, go for it. Hannah A.
You could do the standard algorithm for multiplication.
36 times 5 standard algorithm. Awesome. And I love that. So 6 times 5 is what?
30.
Help me out.
30.
30.
And then 5 times 3 plus 3?
18.
18.
And that's one way to get there. I want 2 more methods. Luca, give me one more. Go.
36 times 10 equals 360 divided by 2 equals 180.
I like it. Give me one more. Come on, somebody else come up with another algorithm for 36 times 5. I really like both of those. Sam, what do you think? Andy, you got anything for me? Come on, what can we do? What if we cut 36 in half first and then multiplied by 10? Brett, go for it.
Wait, never mind.
18. Are you sure?
I forgot.
Okay. And now, guys, I have one more method. This method is called distributive property. Everybody distribute with me. Go. 5 times 30 is?
150.
And then add 5 times 6 is what?
30.
30.
Exactly. And that's a fourth way. So far, we've come up with 4 ways. You know how little kids do it? Little kids, and sometimes big kids like me, will literally do repeated addition 5 times. And do you know what some people do? Ready for this? How many times? Dot, dot, dot.
36 times.
36
What?
times. Oh my gosh. So there's at least 6 ways to create 180, which is really, really cool. Can anybody show me a picture of their graphs right now? I'd love to see what you come up with. I'd really love to see it. So just hold it up to the screen. Show me what you've done. Come on, Jack, I want to see what you've done. Let's see it. Let's see it. And Elliot, I want to see it. Oh, Shar, I think you're going to have to turn off the virtual. Yeah. Oh, that's awesome. That's really, really awesome. All right, Mitch, can I see yours, buddy? And Cooper, Brett, Liam, Sam, and Michael, I don't see video at all, so I can't see yours, but I'd love to. Now, the last thing I want to do with you guys is this. I want everybody to go to page, I don't know. And I know that's not very satisfying. I think it might be page 10.
11.
This is page 11?
Oh,
Okay.
10 and 11.
Okay.
No, 10.
Now, everybody right now, go to page 10. Now, this was the largest experiment in human history. I want you to imagine on March 22nd, 2020, at 7 a.m. in the morning. It's called the Janta curfew. The president of India came on the airwaves and ordered 1,300,000,000 people to lock down. I want you to just think about that. 1,300,000,000 people, which is a pretty big number, 1.3 billion over 7.6 billion worldwide. An unprecedented number of people were told to lock down on one day. 24 hours later, they did a test of 102 cities across India 24 hours later. So now it is 7 a.m. on March 23rd, 2020. And what happened, everybody, is that most of the cities' air quality indices went down, which is really, really good. Down, 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 up, down, slightly down, 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 down. And guys, it continued across India. Every single place, the air level went from A to B and went down. Now, it's an amazing phenomenon to think that that happened consistently across a country. So I want you guys to have some fun with this. Now, this is the answer key, and you'll see that all the plus signs, all the additives represent cities that went up in pollution, but all the negatives are the cities that went down. And there are very, very few cities that went down. So the percentages were truly unprecedented. And now I have one job for you. How are you going to maintain this silver lining in your house? So if you want, when we get back to things, what are you going to tell your parents? What are you going to ask them to do differently to contribute to keeping our planet safe? Especially look at the beautiful Northeast now. It's clear. So I'm going to open it up, unmute everybody, and just start, Jack. What are you going to do?
I'm gonna tell them to only drive the car to places where it's too far to walk.
Wow. I applaud you for that. Hannah T, go.
Mine kind of relates with whoever went last.
That was Jack.
When you're at like the stop sign, there's a, my mom has it in her car, but there's a button. Just a second, but if everyone does it, it will like make the earth better.
No, wait, can you explain that one more time? I had a little trouble hearing, honey. Sorry.
So I don't know if this is in every car, but there's a button that like it stops the gas for I don't know how long. So when you're at a stop sign, you don't have the car running, and it like when you need to go, it turns back on.
Okay, that is amazing. By the way, I find that feature annoying in my car, but guess what? I am turning that feature on, Hannah, because of what you just said. That's awesome. Charlotte, what about you?
So there's a composting service near us, so I've been trying to convince my family to get us to compost. But another thing that my sister and I do, or I'll do next year, is because the bus stop is really close, we walk home from that instead of having our parents pick us up because it's only like a 5-minute walk. But I mean, if just a bunch of people did that, bus stops really close to them, it would be better.
I mean, can you imagine if everybody did what Hannah and Charlotte said to do, and Jack? Andy, what about you?
So I have two things. I also go to a bus stop right near my house, and
Great. You had one other thing?
yeah, I forgot it. I'll try and think of it.
Okay, anyone else want to share what they're going to do? Because I have one thing that I want to tell you that I'm going to do for sure. And that is, do you see this little boat behind me there? So that is where I live for 3 months a year in the summer. Now, it has 2 engines that are 500 horsepower diesel powered engines. And they create, now even though the exhaust is under the water, okay, which is a lot better for the environment, it still affects the water. And I've literally been looking for an alternative energy for the boat. I believe there are now solar powered boats that can get you where you need to go. And I am looking into it. I am definitely trying to get there. And if anybody knows of any way to improve the environment, I want you guys to help. Last comment, and then we're going to say goodbye. Andy, go.
So I've been thinking about this for a while. Maybe like the people that own GPS, they can make it so it like, tells you how fast to go, like to get to the light on time, so you don't have to sit there in the car with the car running.
Wow, that is really cool. Andy, you should start to think of some physics algorithms, and I can help you with that. If you send me some information, we can try to come up with something together. I love it. Now, guys, we're gonna count right now from 10 to the 15th power. This is the amount of molecules of nitrogen dioxide, which is a 1, stop whistling please, which is a 1 with 15 zeros, and that is 1 quadrillion. So we are actually going to go from -1 quadrillion, and we're going to divide by 1,000. Are you ready? Let's go. -1 quadrillion, -1 trillion, -1 billion, negative 1 million, negative 1,000, negative 1,
Negative
and then negative 1,000th, negative 1 million, negative 1 billion. Wait a minute. Are we getting close to negative 0? There's no negative.
6,
2,
8,
4, 6, 8. Oh, athletes, say goodbye to your friends. Say have a great
Goodbye to your
week.
friends.
And silver lining. And I'll stay here until you guys leave. I'll stay here until you guys leave.
Goodbye.
Au
Goodbye,
revoir.
your friends.
Goodbye, friends.
Good night. Avita, say my friends.
Bye,
Uh-oh,
Mr. Kramer.
I started singing. I can't believe it. Bye, guys.
Oh.
Oh, Luca, you're the only one left. Ah!